Hello everybody, my name is Kason Quisenberry, and today I'm going to teach you everything you need to know about soft references in Unreal Engine 5 blueprints. Now the easiest way to understand what a soft reference is to first understand what a hard reference is. Now if you've been using blueprints for any amount of time, which if you're watching this video I recommend you have some experience with blueprints, or you look over my other videos about blueprints first. If you use blueprints for any amount of time, you've definitely been using hard references. Now what is a hard reference? Well, in terms of just easy to know blueprint terms, it's this dark blue variable type right here. So as you see, variable type, this is specifically a reference to another actor, which we'll talk about a bit more. But if you look up, say, any sort of reference, you will get this, and it's going to be this object reference right here. And this can be a reference to literally anything within your project. This could be a reference to a 2D texture. It could be to a material. It could be to a 3D model. It could be to an animation. It could be to another blueprint like this one currently is. So you can also get hard references by using certain nodes. So if we look over here, the get actor of class node or the get all actors of class nodes, these are going to create hard references. Now the way that you can tell this is by this blue pen. So see, if we look at this blue pen right here, this is going to be a hard reference to this actor. Same thing for this array. This is going to be an array of hard references to our actor. It's also with the component. So this is a hard reference to the component, this capsule component, and to this mesh component right here. These are both hard references to these. So it can also be components within our blueprints that can also be hard references. And then also you can make them if you use certain nodes. So here we have this set static mesh node, and as we can see, there's a little drop down menu for set new mesh. Let's make a little cone. Well, I clicked cube, so let's go with cube. This is making a hard reference to this particular mesh. So this is a hard reference, right? So it can be, super easy to actually make a ton of hard references without even knowing it, just by using certain nodes that have these drop down menus. So just know anytime that there is a blue pin, that means you're making a hard reference. Now it might not necessarily be a new hard reference, like this capsule component is not a new hard reference because this capsule component is already a part of this actor, right? For instance, this is making a new hard reference, this is making a new hard reference, and then this is definitely making a new hard reference, right? So just be aware that you're making, hard references all the time. That's not necessarily a bad thing. We're going to talk a little bit more about, when to use them and how to use them. But I'm not saying that's a bad thing. I'm just saying to be aware of that. Now, in terms of what a hard reference actually is, like I said, it's just a connection to an asset or an object. But the way that it works is it's a direct reference, or if you're have a familiarity with C++ programming, it's a direct pointer. If you don't know what that means, don't worry about it. It's totally okay. Just for those of you with a programming background, if you want to, some additional information, it's basically a direct pointer. But this is a direct reference to our asset or object. What that means is that this is going to look for something that is loaded into the game. And if it's not loaded into the game, it's going to load it into the game, load it into memory. Now, something can be loaded into memory without actually being, in the level of the map, which can be kind of confusing. So right now, this shape cube does not exist in my map anywhere. This is like a different cube, obviously. But, let's say it's, just in case, it's a cone, right? This cone is not anywhere in this map, right? But if I was to play the game with this character, it would load this cone into memory, which that can be a little bit confusing and a little bit, technical, but essentially when it loads into memory, that means that the computer is keeping track of it, right? And we don't always want our computer to be keeping track of certain things because it can get expensive. Because say you're having your computer keep track of thousands and thousands of different hard references in your project, right? That can start to get a bit cumbersome, especially when it's in something that needs to be loaded in the game immediately. And I'll sort of go over that a little bit when I go to the reference viewer. Hard references are always going to be loaded into your game. And the reason for this is that hard references are loaded and checked at compile time. Now what that means is when you package the game, right, that's what compile time means. So when you package the game, that's when all of these hard references are actually being put into the game, actually being loaded into the game, actually being checked. So that's why hard references are going to be a lot less flexible, a lot less dynamic, is because you have to have all your hard references set up in working when you have your game package. Because if you don't, right, and we have this hard reference that's looking for something, and let's say it's looking for this actor, but let's say I then just delete the actor, it no longer exists in the game, that's going to completely break this actor. So it's completely going to break our character if it's referencing something that no longer exists in the game, and that could lead to either you getting a compile error, your game not opening, your game crashing or just like some sort of unforeseen error. Now, of course, there is a way to get around, stuff like that. That would be the is valid node that I talked about. This node. This is a way to get around stuff like that, to stop your game from crashing or stop your game from, freaking out by checking to make sure that the hard reference is working. But sometimes, you can be over reliant on this, or sometimes you could be using this as like a crutch to fix a bug when it could be easier just to use soft references. But if you completely just delete an actor or break a hard reference, this reference is basically going to, try to look for whatever you deleted. It won't be able to find it and it's going to break your game. There's a couple of funny stories about this in the gaming industry. I think probably the most famous one is the coconut from Team Fortress 2. So there's basically a JPEG of a coconut in Team Fortress 2. And if you delete it from your game files, or if it's ever deleted, the game just refuses to run. Most likely what it is that this was like some sort of early asset that was maybe used for the inventory system, or like maybe the character select, they just had this picture of a coconut. And most likely there's so many objects and so many actors in the game that just reference that picture of the coconut that if it's deleted, all those hard references break, causing the game to be unable to be compiled. And I know this kind of, that sounds scary, like, oh no, I have so many hard references, is that bad? That sounds like it could be really game breaking. It's not bad. It's just you need to, be aware that if one of your hard references break, or you have a mistake with your hard references, it can break the game and be an issue. And that can also be an issue like when you're compiling, it might just say like give you an error but not tell you what it is. That might be a clue to recheck some of these hard references, make sure everything's working good. And so don't get scared by the fact that hard references can break. That's just how they work, but they are needed, and we'll talk about when to use them and stuff like that. But now that we've explained what hard reference is, let's get to the point of the video. What is a soft reference? So soft reference is right here. As you can see, instead of being a dark blue or like a regular blue color, it's this light, kind of like, I don't even know what that'd be, like a teal or like a sky blue or something. I don't know, whatever color that is. It's this kind of reference. And as you can see, it's the exact same. So this is a reference to our blueprint actor. This is also a reference to our blueprint actor. Everything that happens that makes a hard reference and soft reference different happens on the back end, which is why, it's kind of confusing to talk about and requires a little bit more technical knowledge to understand exactly what's happening. I'm going to try to, make it as simple as I can explain it. But essentially, in practicality and like in practical use, a hard reference and a soft reference do the exact same thing. So just as a hard reference can be, a reference to 2D texture, material, 3D model, etc., so can a soft reference. So anything that can be a hard reference can technically be a soft reference. Just so you don't get too confused, right? This is essentially the same as this. It's just how we handle it that's different. It can be a bit technical understanding the difference between hard reference and soft reference. I'm not going to get too much into the technical stuff, because it's kind of the thing that stops people from using soft references, is like people explain the technical stuff and they kind of get scared of it. But essentially, the main thing to know about a soft reference is that it doesn't require an object to currently be loaded into the game. And if you use a soft reference, that does not then load the asset onto memory. So it's a way that you can save a bunch of memory by controlling when the asset is loaded and unloaded using soft reference, versus a hard reference where the object always has to be loaded. So that allows soft references to be more dynamic and more flexible, because certain things don't have to be loaded in the game for them to work, and you can then control, when things are loaded in versus not loaded in. This makes soft references basically essential for large games, because they're constantly loading and unloading different parts of the map and different actors. Because, for example, if say we need something in Winterhold, we need a certain actor to be referenced in order to make some part of the code work, it wouldn't make sense to make it a hard reference, because that actor would always be loaded onto memory, even say when we're over here in the Reach, or if we're in Riften or anything, right? It doesn't make sense for that to always be loaded onto memory, because that's just wasting the computer's resources and could potentially, lead to large slowdowns. If say, we have something we need in Winterhold and Dawnstar and Solitude and Dragon's Bridge, we have all these different hard references all over the place, and the characters over here not using any of them, but they're still loaded onto the memory, could slow down your game. So that's why they're essential for really, really large games. Now, if you're doing like a smaller indie game, theoretically you can, get away with probably using only hard references, because you can always have the entire game loaded onto memory. But this is a cool way to help with optimization, and it's a very important tool to have. And another good thing about soft references is, say if something gets deleted either from the world, or if it gets deleted in the project, theoretically it wouldn't break anything, right? It would be totally fine. Now, if you need a soft reference because you're referencing something you need for your code to work, say like you need a door to open and you make a soft reference of the door and then that breaks, right? The door is not going to open, right? It doesn't magically like fix all your coding problems, right? But it just stops the game from crashing. Say that we have a hard reference to an item inside of the third person character, but then like it's a key or something. We grab the key and then we delete the key from memory, and now we just like change a variable inside of the character has keys now true, right? Even though we deleted the key from the map, if it's still saying like one of these, or like we have it as a reference, like if this is a key, it's still going to be always loaded onto memory, right? It's never going to be deleted. Even though you deleted it in the game, it's still going to be on memory because it is a hard reference, right? Versus if the key is a soft reference, right? We pick up the key and then delete the key actor from the world, then it's going to be no longer loaded onto memory because there's no hard reference to it, right? And so you can actually be having a lot of different things that are still on memory, still being kept track of, even though you thought that they were deleted, which is why the isValid node isn't like a catch-all save-all, because while it will keep your code working, it doesn't fix the memory issue. Right? Just because something is not valid does not mean it's not being loaded onto memory or it's not being kept on memory, right? And I know that memory can be kind of complicated, but again, that just means more stuff on memory essentially means slower game. That's a bit of an oversimplification. Memory is kind of complicated and all that stuff is a bit complicated, but just know, generally speaking, unless you're trying to do something specific, try to keep low memory, and that's what soft references allow us to do. Now let's go over how to actually use soft references. Now, you don't have to follow along with this because it's not really a step-by-step tutorial. It's more of just like learning about a topic, but just so you understand sort of what's happening, I've made a custom event called test here. I then put it at the end of event begin play. So this will run when the event, when we start playing. And then again, these two are a reference to this actor here. And I've made a custom event called thing work ? And it will print a string showing that the thing did in fact work if this custom event is ran. So that's just sort of the background information. Now let's get into how to actually do stuff. So there's 3 basic ways to do it. Now there are, of course, a couple different ways because it is Unreal 5 Blueprint, so there's a million ways to do everything. But here are the 3 main different ways you need to know. So soft reference, the first thing is this resolve. So this is basically just a converter pin that you'd also see for like float to integer or whatever. You can also get this by going off of this and typing resolve. It'll get resolve soft reference. So what this does, as it says, is that it basically gets the class or object and directly points to it. So if the object isn't already loaded in memory, it will do nothing, essentially. So essentially, this just makes it from a soft reference to a hard reference. Now we can plug into anything that requires a pin. So like now we could just plug, well, actually we can't because this is too specific. But let me get this one. But now we can plug into something like this because we have resolved, versus when it's just a soft reference, we can't do it. However, as you can see, it will basically make one of these. It will basically like resolve it. So just so you know. Now the important thing about this is that this doesn't make it to where it works. So as you can see, there's no BP actor in this world, right? So just doing this will not do anything. So I press play. No string is texted, and then when I hit escape, you'll see we get an error because we tried to use a hard reference to find something that wasn't loaded into memory. Right, so this is basically essentially the same thing as if we just used a hard reference. Right, again, nothing and then error. So it does that. But the cool thing about using a resolve is that it can get a specific instance of something already loaded in memory, and I'll explain what that means. So if I go here, and then let's say I place some of these into the map, let's say that we have, 2, right? And then I go here, I can then go to this reference, and then it's giving us an error because there wasn't one when we started it. But I can change the default value to be one of these. So let's say I make it actor 1. Right, and so now I have a direct link to this one. So now if I was to hit play, right, thing work. But again, let me show you the shortfall. So this is actor 1, I believe. Yeah, this is actor 1. So if I delete this one, see, it's going to give me this error saying it's going to break a reference, which is super helpful. So I'm going to hit no, I don't want to delete it. But if I was to delete it, this would again break. Right, and so that's different from this variable because as you can see, we have this thing here, but we cannot change the default value of a hard reference. but we can of a soft reference. So this can also be useful if, say, you have 100 doors and you need to get a specific reference to just one of them, then you can use this. And you can change the default value to be that. Now let's explain some other ways you can use soft references and some useful nodes for it. So here we have load asset blocking and async load asset. Now these basically do the same thing. What they do is they load in whatever asset or whatever soft object you're using into memory. So like I said, soft references don't inherently have to be loaded into memory. And so these will tell the computer and tell the game, hey, load this asset into memory. However, they do it in two very different ways. So load asset blocking basically does it immediately. And this will cause issues for you if it's unable to immediately do it. Now, what that means is that if, say, I'm trying to load a texture and for some reason the computer is having a hard time finding it, or like maybe the file path's really long and it's having some sort of issue and there's some sort of lag or something, it will stop the game from functioning in order to find whatever soft object reference is being used. So like it'll stop the player from receiving inputs. It will stop the game from rendering other things. It will just completely stop the game. It will even stop like all the code, and the player will basically just be stuck on a screen. Now this could of course, cause soft locks or just like cause a bad player experience, but this could be really useful if the object you're trying to load in, the soft reference you're trying to load in, is vital to having the game run. So if, say, we're using a soft reference to load in a boss to a game that they need to beat in order to progress the game, and there's code that specifically says the boss needs to be defeated or like you can't progress, right? Then you would need to use this to basically stop the player from doing anything else until that loads in, right? And you can technically build a system. It's kind of complex, but you can build a system that detects if a game is buffering or a game's not if a game's basically like loading, and then if it's loading for too long, you can put up like a loading screen or just forcibly crash the game or do something to basically fix the issue or give some sort of warning to the player. I'm not going to go over that because it's a lot more complicated, but that is what the load asset blocking does. It immediately loads the reference, and if it doesn't, it will cause a hitch or just for the game to stop. Now what async load does is that it basically will load it in the background. So as you can see, there's a little timer, a little watch clock thing here, and that basically is the same as the delay node. So it's basically saying that this node takes time. So basically it will load the object asynchronously, so not on the main thread if you're more into programming, but it's going to be doing it in the background while the rest of the game code is working in the foreground. And so this might take a second, right? So if you're trying to load something in, it might be a little slower. It might not load at the exact time. But from my experience, this works, basically immediately most of the time, unless it's just a huge asset. If you're trying to spawn in an entire house in 0.2 seconds, that's not going to happen, right? So that's why maybe you want to put up a system where if the player is, 1,000 yards from this castle, then async loaded in, right? So you just want to be careful with that. And you just want to test what assets. If you want to use this system, you need to test how long it takes to load in and just account for that basically. And you'll see it has two nodes, unlike this one just has one. So this one basically will happen regardless of if object loads or not. So say that we need to load an object and then do an attack. But if whatever this doesn't load in time, then it'll do the attack, right? Because we still wanted the attack to happen regardless of let's say a texture doesn't get changed properly, right? We'd rather a texture not change and the player be able to still attack than the player not be able to attack just because the texture can't load, right? And then this one is for completed. This one's for after the object is loaded in. So say we then have code that references, that material or that animation or something. We would want to do it off of completed. That way we're not referencing something that hasn't loaded in yet, right? Because again, that'll cause bugs. I know that was a bit convoluted and a bit confusing, but essentially the important thing to note is only use this one if it's absolutely critical for the soft reference to be resolved immediately. But 99% of the time you're going to want to use this one. And then code that doesn't rely on soft reference, go here. Code that does rely on soft reference, go here. I hope that makes sense. So I'm not going to use this one. I'm going to use the async, but just know you can use these ones. They can go in the exact same place. They just do different things. So I'm going to use the async load here. And so as you can see, this has a connection for this. I can connect it and then boom, this will load whatever this is into memory. However, currently this is none, and we don't really want to, there's no point really in loading this right now because we don't have a, loading or deloading system based on where the player is, because that's, really complicated. I might do that in a future video, but don't expect it anytime soon. So instead of using a blueprint or something that's actually in the map, let's do something that's a little bit more common with this kind of system, which is load in a different art asset. And then for this, let's change the material of our mesh. So that's going to be this skeletal mesh. We're going to change its material. So what we would do is set material. And as you can see, this of course gives us a material. And let's select, let's go cobblestone for fun, why not? And so as you can see, this makes a hard reference to this particular texture. As I hover over it, you can even see the exact path it's going to that's directly pointing to it. And so this is making a direct reference to this. Again, this texture is nowhere in this map you see, right? It's not loaded into the map anywhere. The only two textures that are loaded are this brick, this water, and I guess technically this grid is loaded. Nothing else is loaded. If we were to put this cobblestone in here right now, it would be loaded the second we press this button. So right now, even though it's nowhere in the map, again, that cobblestone material is on our memory. The computer's keeping track of it. That means it's slowly wasting our computer's resources, right? Which we don't want. Now, something like a material, obviously, like one material is not an issue. The issue is if, say, there's 1,000 materials in your player character blueprint, or if there's 1,000 of another type of assets, right? It builds up over time. No one asset's going to cause the issue, but it's just having like the dozens or hundreds that causes the issue. And so what we can do is hover over this. We see it's a material inference object. So I'm going to go to variables, hit plus. I'm going to just call this material 1. So now I'm going to change this to the material inference, the material interface, sorry. So material interface, and again, we're going to click soft object reference. And then, so this is the same as the material. So this is the same thing as this, but this is soft reference, this is a hard reference. So I hit compile. It's going to give me a default, and then I'm going to go to, what did I have? Cobblestone, cobblestone. So now if we get this material, we connect it here. Let's ignore this node for now, this node up here. So boop. And again, this is running off event begin play, so it should happen the second we start up our game. Right? I hit start. As you can see, the material does not change. This is because that material is not loaded into memory. This does not load anything into memory, and specifically it says if it's not already loaded into memory, it returns nothing. Right? So then how do we make this work? So what we do is we use this node. Right? So then we plug this in here. And again, since this code is reliant on this being loaded in, we do completed instead of this one, which would just do it regardless, which would cause an error, or potentially just do the same thing, which is nothing. So that's why we want it off of completed. So now if we go here, take a second, boom. I think the reason it took a second shouldn't be because of the soft reference. I think it's just because, yeah, my Unreal hadn't processed that texture yet, so that's why it like buffered for a second. But now it should be fine, and in the game theoretically it would be fine as well. Now, an interesting thing to note is, as we can see here, we have two textures, the brick and the water. So if we were to ignore this, right? So put that up here, and then just make this, you know, brick. I believe it's that one. Even though we're not using this one, it'll still work. And the reason it still works is because we already have it loaded into memory, because this object has the texture loaded in. So because that texture is already loaded in, it already exists on memory, and therefore the soft reference is able to find it. So anything that's already in the game, in the level, already on memory, can be accessed by a soft reference without doing this loading. But it's probably good to go ahead and load it just in case if there's a possibility that it's not already loaded in, you should always use this just in case. And so this doesn't just work for materials, this works for anything. This works for 3D models, this works for animation. That's a huge one that people don't use it for, that it's really crucial to use it for. If you have like 30 animation montages, that's going to tank your memory if that's loaded in every single time the character's in the game. But if you have them all as soft references and are asynchronously loading them in when you need them, that's going to save you a lot of memory. So again, don't limit yourself to just materials because this was the examples. It can be materials, static meshes, 2D images, audio, anything you can imagine. All right, so that's a way that we can save memory. And now let's go over how you can actually check that to make sure. So there is a thing called the reference viewer. You might have heard about it before. We right click here and then we go to our reference viewer. It's going to open this up. Now this can be super overwhelming, so don't worry, it is okay. But what this essentially does is this shows us every single thing that is being referenced by our third-person character. It also shows what references our third-person character. So here we have the third-person game mode, and this is the... Okay, ignore the object redirector. That's just because I deleted a folder. So ignore this. But we have the third-person game mode. So anytime the third-person game mode is loaded into memory, that means our third-person character is loaded into memory. That's very important. And that also means that everything after this that's being referenced is loaded when our character is being loaded in. So as you can see, right, we have like our standard macros, which are obviously important. We have this actor because we have this reference, right? So because we have this object reference, right, that means that every single time that this character is loaded into the game, into memory, that this is being loaded into memory, which then means, look, static mesh being loaded in memory, static mesh being loaded in memory, material, all being loaded into memory. Now, of course, this isn't necessarily bad. Like, for example, for the third-person character, anytime we have that loaded in, we're obviously going to want to have our animation blueprint loaded in, because if not, then the animations won't work. And then same thing with the controls right here, right? We would always need these loaded in, because if those aren't always loaded in, then the character wouldn't work, right? Now, these are all the white lines, but you might notice there are pink lines. What do those go to? Well, this goes to the map, which actually not sure why that's happening, so we're going to ignore that. And now we have a pink line to our ground texture, right? So this is basically saying that when this is being loaded in, that does not mean that this is being loaded in, right? So that's how you can tell if something is being loaded in by your character or being loaded in by an actor, because any actor has it. So like, for example, this one has it as well, this actor as well. And this is a good way to look at your reference viewers and see, what is being referenced and what is not being referenced and what's being loaded into memory. So again, we go here. And basically, so we can see that this is referencing this. So every time this is loaded in, this is loaded in. Every time this is loaded in, this is all the stuff that's being loaded in. Right, so this is a very useful tool for optimization and for knowing what's a hard reference and what's a soft reference. So again, hard reference white, soft reference pink. All right, now let's go over class references. Now again, you've most likely been using hard class references, like as you've been using Unreal, but I'm going to teach you about soft classes references. Now, the important thing about this is that they both are going to work the same. So I'm going to explain generally what the difference between a class and an object is, right? But just know that applies both for hard classes and soft classes. But I'm only going to, go over once. So these are references to very specific objects. These are references to, like, as you can see here, this is specifically referencing this one object. Even if I have a million of these, a million, billion, jillion of these, right, this is only ever going to reference one of them. Same with this, right? That's why you have to cast to a specific one. That's why you have to get an object of a specific class, right? Because this is only going to reference one. Specifically for this node, it's only going to reference the first one that it finds, which is most likely going to be the first one in the outliner. But sometimes it might not be, which is why it can be confusing. Which is why I recommend only using this node if you only have one of that entire actor in the entire game. Is the only reason you should use this node. And if not, you should use this node and then use some sort of system to figure it out. Or you can use specifically soft actor reference, or again, you can, cast or whatever. This references the entire object as a whole, right? So this is going to reference not any of these actors, but reference this actor, the actor in the content browser, right? It's referencing the entire thing as a whole versus one specific thing, right? So it'd be basically a reference to all of these, but not to any of them actually loaded onto the game or loaded in here, but just to the thing as a whole. And same for soft class reference as well. So as you can see, we can do BP underscore actor, and we can do the same thing here, and they work the same. Now, I said you might have been using these before. The reason is because these are on some of the nodes. So as you can see here on this node, get actor of class, we select a actor, we select a class, right? Which is basically, you know, a type of object. So we reference a class here, we reference a class here. And then the main one you might also use is spawn actor of class or from class. And that specifically references class. So as you can see here, boom, that references it. So we go here and then let's just get player or get actor transform. Let's just do this here. So if we go here, let me go ahead and delete these. I hit play. As you can see, one spawns. It doesn't spawn right on top of me because obviously it wouldn't, but we get a spawning from that there. Now, it's the same thing though. The same issue occurs is that now we have this class loaded onto memory for our entire game. Every single second that the third person character is on screen or like working or loaded onto memory, which should be, you know, 99.99% of the time in any game, right? This class is going to be loaded onto memory, which could be wasting your game's resources and the computer's resources. So we can actually use this soft class to spawn an actor without having it loaded onto memory at all times. So let's do that now. So I'm going to remove this and then compile. It's going to compile. It's fine. Okay, it's freaking. Okay, I'm just going to make a new one because it's freaking out. Right, it's cool. Okay, so now we have this, and so we have our soft class references. Again, that's there, and we're just going to keep the same transform. Again, this is where you make the decision whether you want to do a load class asset blocking or an async asset blocking. Again, it just depends on how important the object is. I'm going to do an async. So we're going to do that. And then we're not going to plug this in here because as you can see, it doesn't work. But what we are going to do is we're going to, I should actually break that. We're going to cast to actor class. Now what this is it's essentially the generic. This is basically a generic actor. So basically every single thing in the game is an actor, right? And this is basically just the parent of every single thing that is an actor. So it's a parent of the character, it's a parent of this, it's a parent of everything. And the fun thing about this is that it's always loaded into the game, right? Because if there's an actor in the game, that means this actor class is loaded into the game, which is good for us because we can now just cast to this. And since it's always loaded in the game, it's not costing us any additional memory to have this in the game. So now what we do is do this, and it's going to get this class and spawn it via this. So if we do here, boom, spawns in. So that's how you can spawn something in Unreal without having to have it constantly on memory, which is super useful. This is super useful if like you just have a bunch of enemies that you need to spawn but don't want to have all the enemies loaded in. If you have a game with a lot of projectiles that the player throws or shoots out of something, right? This can also be used for that to make sure that you don't have to have every single, you know, grenade or every single kind of object in there always loaded into the game. And this is just like a really efficient way to use spawning. I've started to where this is the only way that I spawn anything now, just because I know it's going to be super efficient and it's going to like be an easy way to optimize the game, and it works the exact same as using, you know, the hard class reference. All right, now you might be wondering, when do I use hard references? When do I use soft references? Now the thing about coding is that there's a million billion different ways to do different things. So technically you can use either one for every scenario. Like there's probably a way to use a soft reference for everything, probably a way to use a hard reference for everything. Issue is going to be performance or memory. And I've seen a lot of conflicting, you know, forum posts and even like articles that disagree on exactly when to use hard references and when to use soft references. But from what I understand, the general consensus is that if a object is always loaded into your game, like the player character, there's not really a reason to use a soft reference because you're not really gaining anything from it, right? Because the player is always going to be loaded into memory, loaded into the game, there's no real reason to not use a hard reference to it because you can't, double load the character onto memory. That's not, how it works from my understanding, right? So it's always going to be loaded. That means it's totally okay to get a hard reference. But you still can get a soft reference. Like, that's still totally okay to get a soft reference to your character. The only thing, though, is that a hard reference is technically faster because it's technically going to find it quicker than a soft reference. And of course, when I say quicker, we're talking about, frames. We're talking about, hundredths of a second, thousandth of a second, right? So not necessarily super important, but technically a hard reference is faster, right? So that's why when you use something like the player character, you can always use a hard reference. Now, again, feel free to do your own research about that because there is conflicting opinions, but yes. And if it's not, besides the player character, if there's something that you're always certain is going to be in the game, something that's never going to be unloaded, something that's going to be always loaded into memory, say like the player only has one gun that they have, right? It totally makes sense to always have that gun loaded in, then it's okay to use a hard reference. Or if, say, like the ground of your game is the same ground in all of the game and it's always loaded in, then it's totally fine to use a hard reference for that, right? Because you're not saving memory. The whole point of like soft references is typically to save memory and to be more efficient, right? So if you're using a soft reference at a point that you're not saving memory, then there's no point in using it, right? Or if, say, like this could even, apply to texture. Like, say that there is an important, like every single time the player gets hit, right? They change to like a slightly red texture to show that they've been hit, right? It doesn't make much sense to make it a soft reference because you're going to be loading it in and out constantly, right? And so that in itself could have performance issues, right? Like if you need to asynchronously load a texture, like, let's say that the player could get hurt 12 times in under a second. If you have to asynchronously load a texture 12 times in 1 second, right, that could cause performance issues. So if it's something you're constantly loading in, just constantly over and over again, right, it doesn't really make much sense to make it a soft reference. Go ahead and make it a hard reference. So I hope that makes sense. So if something is always loaded into memory, critical to your game running, hard reference. If it's something that you're spawning in, if it's something that you're going to destroy halfway through the game, because again, that would break a hard reference, but something you're going to destroy, if it's something you're going to load in only occasionally and not like several times per second, then make it a soft reference. Okay, that's going to do it for this video. I hope that all of that made sense. I know that this is probably the most technical video that I've made. I did a lot of research for it from some different articles and some other really great YouTube videos. I just felt that a lot of the information it gets so highbrow so quickly that it's hard to understand, especially like if you're, newer to Unreal. And I feel like a lot of the information is spread across a lot of really useful articles. So I was hoping to put everything into one video. So hopefully this was helpful. I'm going to put a link to some of the articles in a playlist to the YouTube videos I used for this video in the description below. They get into a little bit more detail about certain things and how to use certain things. So definitely go check that out if you're really interested in soft references. And again, also, a lot of the stuff I read was, conflicting. There's a lot of differing opinions. So there is a chance that I got something wrong in this video. And if that's the case, please leave a comment. I'll make sure to put any corrections into a pinned comment above. So be on the lookout for that. But I did a lot of research into this. I was really, wanting to make a video that you don't have to know a lot about data processing to understand. And hopefully I did that. And yeah, like I said, this video is definitely a definitely calmer, less technical version of the video. So if you're looking for something more technical, check out the playlist below. But yeah, I hope that you now understand everything you need to know about soft references in Unreal Engine 5 blueprints.